Hi everyone! Many students often find it confusing to differentiate between the inner and outer parts of a function when performing differentiation, mainly because composite functions involve multiple layers that interact with each other. To make this concept easier to visualize, the rainbow chain is used as an example because its layers are clearly visible. Each layer represents a different part of the function, helping students understand which internal function should be differentiated first and how the process continues outward. This layered analogy makes it easier to grasp the concept of the chain rule and ultimately solve dy dx more effectively. Here is how the rainbow chain works. We have provided a question to visualize and determine the multiple layers of a function. The question looks complicated at first, but after using this method, the equation can be more digestible and easier to solve. Firstly, we can identify the outermost layer, which is the power of 4 function. The second layer is the tangent function, while the third layer is the secant function. The fourth layer is the exponential function and the lone function together. The innermost function is the quadratic and linear function. After identifying all the 5 layers of the given function, we are able to solve dy dx with ease when we solve one by one starting from the outermost layer. Firstly, bring down the power of 4 and reduce the power of tangent to 3. Secondly, differentiating tangent will give us secant squared. Thirdly, differentiating secant will give us secant multiplied with tangent. The fourth layer can be differentiated by using the copy back, lone base and differentiate power for exponential function, while for the lone function we can use 1 over the fourth layer multiplied with the differentiation of the fourth layer.
Is to help students easily understand the difference between the inner and outer parts of a function. Many students get confused when trying to see which part comes first. So this activity uses the idea of a rainbow chain to make it clearer. Just like how a rainbow has layers, a function also has layers. By seeing it this way, students can better recognize which part is inside and which is outside, making it easier for them to solve problems step by step.
The second objective is to help students find the value of dy dx more accurately and with greater confidence. When students can clearly identify the inner and outer function, they are able to apply the chain rule correctly without confusion. This not only reduces careless mistakes but also makes the process of differentiation smoother and less stressful, allowing them to feel more assured when solving derivative problems.
Remembering innovations gives a great impact in the teaching and learning process because it makes the concept of inner and outer function easier to understand. Students are no longer confused when trying to identify which part of the function comes first and which comes later. The clear layers of the rainbow rings help them visualize the structure of a composite function in a simple and interesting way. As a result, students become more confident when facing differentiation questions. They can apply the chain rule correctly without hesitation, leading to more accurate answers and an understanding of the differentiation.
We use a rainbow ring concept to represent each layer of a function. Each color shows a different step in the chain rule, so students can see the process clearly instead of memorizing formula. Through this design, students are not only learning by listening, but also by seeing and touching. This helps them understand how the chain rule works step by step. Compared to traditional teaching method, our innovation make learning more interesting, interactive, and easier to understand. It also helps students to remember concepts better and reduce confusion.
Our rainbow ring creation has a lot of commercialization potential and it is suitable to be used at workshops, math fairs, and classroom demonstration for education. It also has a lot of potential in collaboration with STEM product developers. For our rainbow ring creation, we have received the Silver Award and the first place for the Special Jury Award from the InnoMath competition, which was organized by Johor Matriculation College.